Hi, good afternoon. This is Mr. Vandergriff, and today we're going to talk about density. And we want to answer the question, how dense is Mr. Vandergriff? So first, let's talk a little bit about density. Remember, density is mass per volume, or mass divided by volume. But really, what does that mean? Basically, that just means how much stuff is in a certain area. How much stuff can you cram or squeeze or compact in a certain area? How many atoms or matter or mass can you squeeze into a certain volume? And so today we want to find out how dense Mr. Vandergriff is. So think about it for a moment. What are the two things that you need in order to calculate, to figure out density? Yeah, that's right. You need to know the mass of something, and you also need to know the volume of something. So let's go ahead and find out what is my mass. So I've got a scale here. So we go ahead, stand on the scale. Find out that I weigh 147 pounds. But I'm going to go ahead, there's a little button down here, and I'm going to switch it over to kilograms. Because remember, scientists use metrics. We don't use the English system, although Americans do. We're pretty stubborn, and we're one of the only countries in the world that still use the English system. But all scientists worldwide use metrics. So right now, let's see how many kilograms my mass is. It's 68.8 kilograms. That is my mass. Alright, so what I'm going to do is I'm going to go ahead and I'm going to climb inside here, and I'm going to go ahead and displace a bunch of water. And then I'm going to climb back out, and I'm going to go ahead and grab this 2-gallon bucket, which is equal to 7.5708 liters. And what I'll do is I'll come over here, grab some water, and we'll fill this up all the way up, and then I'll know my volume in liters. And then we can go ahead and use the formula D equals M over V to calculate the density of Mr. Vandergriff. So here we go. I'm climbing inside right now. It's a little cold. Okay, and as you can see, I'm displacing water, a lot of water, and I'm going down, but I need to go all the way under. So here I go. What happened is when I went right down under and displaced the water, the tape ended in the video. So as you can see, I'm wet and I have to get back in there a second time. I'm not looking forward to that, but I give 100% effort when it comes to my teaching to get these science concepts across. So here I go, one more time. Back in. We're calculating the volume of Mr. Vandergriff. Here we go. And I'm going to go completely under. Okay. Now you can see I've displaced a lot of water. I've displaced the exact amount that my volume of my body. Now Archimedes discovered this. He's one of the greatest mathematicians, a Greek mathematician, inventor, and physicist of all times. And he was actually in the bathtub, and when he went down, he saw the water go up, and he freaked out. He got so excited, he ran down the street screaming, "Eureka, Eureka, I found it," not realizing that he had no clothes on. He discovered this breakthrough when it comes into density. So here we go. I'm going to get out now. I do this, and I'm going to go ahead, and now what I'm going to do So I'm going to take this bucket, that's a 2-gallon bucket, and remember that 2 gallons is equal to 7.5708 liters. And remember that in scientific community, scientists use liters. We don't use gallons. That's the old English system, right? But in America, we're pretty stubborn and independent, and that's what makes America America. But pretty much the rest of the world and all scientists use metrics. So that's what we're going to go ahead and use metrics. Here we go. Starting to pour over right there. And we're at the halfway mark. So we have 8.5 2-gallon buckets to fill up the volume back up to here. So if you take 8.5 and multiply it times 7.5708, that equals about 64. 64. So it's 64 liters. My body took up 64 liters. That was the volume of my body. So if we take 68.8 kilograms divided by 64 liters, we come up with 1.075 kilograms per liters. That's my density. But if you convert that to grams and cubic centimeters, that would convert to 1.075 grams per cubic centimeter. So Mr. Vandergrift's density is 1.075 grams per centimeter cube. Now, if you remember, let me grab a couple things over here. If you remember, the density of water is 1. So if something's density is greater than 1, it's going to sink. If something's density is less than 1, it's going to float. So take a look at this apple. It's coming back up, barely. So we know that its density has to be just a little less than 1. How about this mango? Oh, there we go. It's coming up a little slower, so it's probably a little more dense than the apple. How about a banana? So it's less than 1. How about this? Yeah, that's really less than 1 right there. But my density is 1.075 grams per centimeter cube. So I'm just a little bit more dense than water. Which means that when I'm in a pool and I blow all the air out of my lungs, which I did in here, I will sink. So you can go ahead and try this when you're in a pool. When you're in the pool, blow all the air out of your lungs. And then you'll see that you will be just a little more dense than water and you'll sink. Because remember, most of your body is made up of water. But again, make sure you can swim and make sure you're in the shallow end. If you can't swim, and you might want to have a floaty, but then that might not work. Just remember, any good experiment, you have to repeat it to get accurate results. So we want to find out how dense another Vandergrift is. Who do I have here? Why don't you introduce yourself nice and loud?
Hello, my name's Samuel.
And we're going to find out, Samuel, what is your mass?
53 pounds.
Okay, but if that's in kilograms, how much is that?
24.
Can you say that a little louder?
24.
Okay, so remember, for density, we need mass and we need volume. So Samuel saw how much fun it was when I did it, so he wanted to give it a try. So Samuel, go ahead and climb in here slowly. Put your hand right there. Lower your body in there.
Dad, it's so cold.
Okay, you're gonna go ahead and you're gonna just touch the bottom.
Okay, I'm on the bottom.
Okay, and I want you to go all the way down. Okay, and stay down there.
Dad,
just for
I can't do it.
You can do it. 1, 2, 3. Awesome.
We're gonna find out what my math is.
Go stand. Down on the scale. So you are 43 pounds. Okay, get off. And then I'm going to change this. Okay, get back on. We're going to find out how many kilograms. You're 19.4 kilograms.
Hello, I'm Samuel. Hello, I'm Zoe. And we're here to find the density of my sister Zoe.
And what are the two things we need for density?
Mass and volume.
Okay, and so we've already got the mass because she went on the scale. What's her mass in pounds?
43 pounds and 19.2 kilograms.
Okay, so how are we going to get the volume of Zoe?
By putting her in this RSES Ramona Disposal Service recycling thing.
And it's going to displace, say it's going to displace water.
It's going to displace water. I can't get it.
Okay, so why don't you help? No, you're fine.
Here, I'll hold him. Okay. Dad, I can't get him.
Okay, so you give me your hand, and you're going to have to go all the way in, Zoe. Okay, wait. Now, in a minute, you're going to have to go all the way down and hold your breath, and then come back out, okay?
Are you touching the bottom? No. Okay. Let me do it.
Okay,
Hold
go.
your breath.
Okay, climb out now. Climb down, please.
I'll do it again.
What?
I'll do it again.
Not yet. We gotta fill it back up. Okay, come on.
I'm real. After this, can I do it again?
Maybe.
Because it's warm in there.
So, what are we gonna do to find volume? That's right. You're gonna multiply length times width times height, right? You're gonna use a meter stick. No, that's not gonna work. Remember, that's for a regular object. For instance, here's one of Samuel's favorite books, Voyage of Dawn Treader. And so, all we have to do to figure out the density of this is go ahead and get its mass, and then second, we go ahead and we get its length and its width and its height. We multiply those together, and they come out to be cubic centimeters. But what if, that's for a regular object, but what if you have something like this really cool transformer, and this is definitely not a regular shape, this is an irregular shape. So what we need to do to find the volume of this, very simple. You can see right behind me, we have a Ramona disposal recycling bin full of water. So all we have to do here is place the irregular object, and as the water rises up or the water is displaced, then we pull it back, and when it goes down, if we can calculate how much space, how much water was displaced by the item, the object, then we can calculate the volume in milliliters and then convert it to cubic centimeters. So, let's go ahead and try this. We've got our scale. We've got our Ramona Disposal Service recycle bin full of water, as you can see here. I've got a ladder so I can actually get into the water. And then over here I have 3 containers full of water. And lastly, I have a 2-gallon bucket. 2 gallons is equal to 7.57. 2 gallons